Hello, folks. We will be working on Module 6, Day 3, Prisms and Cylinders. So a prism is a fancy name for any solid. Most commonly, people think of a box. We have boxes here, but prisms can also have other shaped bases. So these have rectangular and square bases, whereas a Toblerone, when it's laid sideways, by the way, the base is down here, it has a triangular end. And you can have hexagonal prisms, you can have trapezoidal prisms. It can be any shape, solid, that has the identical top and bottom pieces, and then they're connected by sides of rectangles or squares. So the Toblerone has a triangle here, but if you rotate it around, all these sides are rectangular. So that is a prism. The volume, we're going to be focused on volume. Okay, we've learned about sectors and arc lengths, and then the rest of this unit will be on volumes. By the end of the unit, it's all formula based. So the volumes of a prism, the basic one is base area times height. This base area can be replaced by whatever shape you have for that prism. We will only have 3 possible shapes. We will have the rectangle, which would be length times width, or it could be the square, right, with everything the same. Well, guess what? That's the same as length times width. It's just that you're using the same number. Or, and you might remember this from the end of last lesson, we could have the triangle, which is length times width divided by 2. So it's half of a rectangular square. Here we go. This is your basic prism. It's rectangular prism. So we're going to find the volume. It is base area times height, which in this case, because it's a rectangle, it's really length times width and then times height. So this has been replaced with our area formula. Easiest volume you'll ever find besides the cube, because you basically just multiply these numbers together. So it's 4 times 10 times 8. Does it matter what order I multiply these? Absolutely not, because order of operations says you can multiply in any order and you get the same number. So this is 40 times 8, or 320. And these are cubed units, because volume is the area of space that fits inside of an item. And so you measure that in what I like to picture like little ice cubes. Or if you can picture a Rubik's Cube, all the little side pieces, you're counting how many of these little guys fit in here. That would be volume. All right. Number 2, this is a triangular prism. It's I actually have an item like this in my classroom. I tried to take a photo of it. It's one of those clear items that you can look through, and they can make cool colors. So this is the triangle here. So I will redraw it just so that we can, because there's a little complication with this one. And then that's 4. We'll get to it. Okay, base area times height is the volume. So for this problem, our base area is going to be length times width of the triangle divided by 2. And then we're going to multiply that by height. So that's going to be the hardest part, is figuring out this triangle. This triangle does not have length and width there. Length and width must be joined by a right angle. So we have to divide this triangle in half to get a right angle in there. Good news, when we do that, because the 2.5 was identical, making isosceles, the bottom is cut in half. So now there's a 2 right there. So what you now really have is a right triangle that you can use Pythagorean theorem on to get the height or the length, depending on what you're using for the terms. So 2 squared plus what squared is 2.5 squared. That would be the setup. I'm not going to show all the steps because by now we have used Pythagorean theorem quite a bit. 2.5 squared minus 2 squared. So that's 2.25, the square root of. And I get 1.5. So this is 1.5, which means this is 1.5. And the base is 4. So when I go to use this formula, it's 4 times 1.5. And then I'm going to divide all of that by 2. And then whatever I get there, I'm multiplying by the height of 5. Now, the term height doesn't necessarily mean the item is standing up and down to make that number. But this prism, if we stood it so that the triangle was on the bottom, it would be 5 units high. So now I'm going to multiply this out. I've got 4 times 1.5 divided by 2, and then I'm multiplying that by 5. And it looks like I got an answer of 15 cubic centimeters. So notice you can either put the little 3 on your units to be cubed, or you can put cube before it, and everyone understands that. All right. Now we have what's called the cylinder. Cylinder, we could say, is a prism with a circular base. The formula is the same, but even easier, because there's only one formula you can put in there if it's a cylinder, and that's pi times radius squared. Yay! Okay. Easy peasy lemon squeezy. However, you will have to have some answers with pi remaining and some as a decimal. So we'll practice both. Let's find the volume of this guy. Volume is pi times radius squared times height. Sorry, I got a little distracted there for a minute. So pi times radius squared times height. So 1.5 times 1.5 times 4. And I get 9. So in terms of pi, I would write the volume is 9 times pi, and these are inches cubed. As a decimal, I'm simply going to multiply 9 times 3.14. And I got 28.3. So there are our two answers, with pi in the answer, using 3.14 as pi and rounding to the nearest tenth. And this one, got some fun with a fraction. Volume is pi times radius squared. Be careful, I gave you the diameter. Oh, snap. And then times height, which is, that is supposed to be, that's really funny. That is supposed to be 9 3/4 like that, which would be the decimal 9.75. Crazy hatch. Let's multiply out the numbers, ignoring the pi for now. 3.5 times 3.5 times 9.75 is 119.4 times pi. Okay, making sure I did that correctly. And then for the second answer, it's approximately, so now I'm going to take that 119.4 and multiply that times 3.14. And I get 374.9. What were our units? Inches again. So we'll do our units. There you have it, folks. The prism and the cylinder, they have a similar thing. They have a shape that's the same on the bottom and top. Whoop. And then when you look at the sides, it's rectangular. If it's a prism, you can see the sides rectangularly like so. If it's a cylinder, pretend you see the soup can and take that label off. When you fold it out, it's a big old rectangle. Boom.